Today we'll be going over lazy loading and why and how is this a money saver for your website. This video will be divided into 3 parts. The first one we'll talk about what lazy loading is, how is it saving you money. This will be in the slides. Then on the second part I will show you a one-line solution for lazy loading which does improve your performance, but it's not that professional. And in the third part, we'll go over a very professional solution for lazy loading and how you can get all the benefits from lazy loading. So lazy loading is a money saver. How does that work? Well, what if I told you it improves the performance of your website, it improves your SEO, and it also puts less strain on your database and bandwidth? Let's go over the concept of lazy loading first. The first example will be the normal bad example whenever lazy loading is not implemented. First, you visit the website. Then your site and files and HTML are scanned and all images are downloaded simultaneously. And after that, the images are loaded. This is the bad approach, the slow approach, because a lot of time goes between downloading and loading the images. Now, the faster and more professional approach requires one extra step in between. First of all, you visit the website. Then, instead of the images, you instantly load some dummy images. These can be some little SVG icons and a little skeleton made with CSS and HTML. Then, as you scroll, only the visible images will be downloaded because of lazy loading. And then you load the image. And by downloading only the visible images, you provide a much better experience and it takes way less time for your site to load. And then we come back to the beginning. Lazy loading is a money saver. It provides faster loading, better ranking on Google, and less calls and less bandwidth used by your database. Now that we've discussed this, let's go over the simple, less professional approach for lazy loading. If I refresh the page, the images load instantly, but that's because it relies on my internet. Let's open up the network tab by pressing F12, and you can control how fast or how slow your network should be. There are some presets here like 3G, offline, slow 4G, fast 4G, but I made a super slow custom one. That's something you can play around on your own, but let's just select super slow now. Also, you could disable the caching, just close this and reload. The loading of the first few images is fine. It still takes a little bit more time though, and as I come down, they just gibberishly load in. That's not exactly what you want. And also in the network tab, if you look at images, you can also see which images are downloaded. And all of the images are downloaded right here. You can see some of them are still pending. I could also zoom in more if that's more visible. But generally, you don't want to download all the images at once. So to solve this issue, I just select all of the images that I have. And then there is a property on the images called loading. And you can set the loading to be lazy. It's eager by default, which means it loads the images immediately. And lazy will defer the loading until you're about to see the image so that it's already somewhat loaded. I save it now. It will refresh. I will enable caching and I will also put no throttling back on. And now instead of downloading all 9 images, it downloaded only the first 5 because those are the visible and upcoming images. If I scroll more, you can see image 6, image 7. They are constantly being downloaded, but not at the same time, not at once. Image 8 and image 9 is also downloaded now. That's it for the simple approach. Let's move on to a more professional one. Here we are. It obviously will be a bit more complicated, but let me show you how it looks. If I refresh, there are some little animated skeletons before the images are presented. And then as I scroll, you'll see the skeletons and the images animating with the opacity animation, with the fade in animation. If I switch to super slow now, and then close the network tab, if I refresh, you'll see that those have a little bit of animation. Unfortunately, super slow is still not slow enough. They should be animating with a pausing animation, but then they load constantly just right in. Now let me explain the HTML and the CSS, and we write the JavaScript together, coding along with me. First of all, there is a wrapper that holds all the images together. That's clear. And then there are all these images, which I will comment out for now just so it's more separated. and we'll break down one of these because all of them are the same. We have obviously loading container here that contains everything. On the same level, we have a loading overlay and our image, and the image is of course set to be loaded lazily. And inside the loading overlay, there is just a loading image and there is a little SVG inside. That SVG is, if I refresh, what you see right there. So it's very simple. You don't have to overcomplicate it. You'll be able to access the source code. And as for the CSS, the wrapper has some basic stylings. It's using Flexbox and FlexWrap to make it responsive. The loading container also has an animation of type pose, and the loading overlay is positioned absolutely so it can appear in place of the image. And here you can see some further stylings. And in the meanwhile, here are our animations. One of them is the pose animation and the other is the fade in animation. I don't want to waste too much time on these classes. Since you have access to the source code, you can analyze it at your own pace. Now here is our JavaScript. I will delete all of this and start writing it together. First of all, let's create a constant variable. I will call it images, and we'll simply select with the query selector all the loaded images. So we select all the images that have the loaded image class. We'll be needing this later. For now, let's create something called an intersection observer. I will call it observer. And this intersection observer, the duty of this is going to be to monitor our images and tell us and trigger some functionality whenever the image is inside the screen. So for example, 10% of the image is already visible, then we should start loading the image. We do that by creating a new intersection observer, then parentheses, and here it will receive an arrow function, a callback function. And as for its arguments, there are some basic arguments, which is the entries. The entries will stand for the elements that we are currently monitoring. And the second one is going to be the observer, which is going to be basically itself. Inside the function, we go over the entries. So and with the for each loop entries.forEach, I could also call this image, and then the entries could also be called images for this example. So maybe let's just do that. So we go over the images, and if the image dot is intersecting, which means it's visible in the screen, then we do something. For example, load the image, and I will just console.log out here the image. The intersection observer has a second argument as an object, and here there is a property called threshold. Now this threshold can be set to a value between 0 and 1, 0 being 0%, 1 being 100%. It will mean how much, in this example, the image should be visible before the is intersecting value is triggered. For here, I set 0.1, which means 10% of the image should generally be visible before we do anything with the is intersecting value. And that's great, but none of the elements are observed yet. So none of them are monitored. And to solve that, remember we grab the images up here. So we'll go over them with a for each loop. And to add the image, I will first of all say observer.observe. And then we observe the image. That just basically adds the image to the array of the observer, which he eventually monitors. And here, because I console logged it out, if I just refresh now, you'll see an intersection observer entry, which is basically this little image that is bubbling around here. But if I scroll more and more images will appear, and that means the is intersecting value is working. It's actually recognizing that the images are coming into the screen. That's great. And above the observer, I'd like to add the function which will be called when we are loading the image, and this function will be called FadeInImage. It will receive an image as the node. I will assign the image that it receives as an argument an event listener. So add event listener. And here we have to add an event that it will actually listen for. And I say listen for the load event. As the second argument, it accepts a function. So I give it an arrow function. And inside this, I will say yet again an if statement if the image dot complete. The complete value, something you can call for an image, so an actual HTML image, not something you set as a background. And this will mean did the image successfully load. because if it did, then I'll assign it an animation, this.style.animation, and this will be equal to the fade in. Remember, in our CSS, that's the animation we called it, fade in. It will be 2 seconds long, and it will be with the ease transition. And that's not yet enough, because if the animation ends, it will go back to opacity 0. So I'll also say this.style.opacity equals 1. Because the loaded image is already hidden with the opacity 0, we have to set it back to opacity 1. And now all I have to do is call the function here, FadeInImage, and I'll also remove the console log here and pass in the image that we are observing. That's great, but then why are we not seeing the image if this is supposed to work? Well, that's because there's an absolutely positioned element above this one. This little skeleton is covering basically our image. And to solve that, I will come back to our function into the load event listener, and before it loads, I'll get dynamically the skeleton container. So const loading overlay, this will be equal to the image dot previous element sibling. And actually I have to get this before the load, so outside of the add event listener, but I'll be changing its styling. For example, the loading.style.display will be changed inside the event listener, and it will be set back to none. And now we are being thrown an error because image.addEventListener is not a function. That's because when calling the function, I cannot pass in the image, because then it's an intersection observer entry. What I need to do is pass in the event.target, which will be equal to the image that we are passing in. Now it's loading in, but the animation from its parent is still in there. So what I need to do now is get the loading container. So below the loading overlay, I will get the container, loading container equal to the image.parent element. And where I set the display to none, I will also say loading container.style.animation equal to none. Now the animation stopped, and we are almost done, but there are a few more things we have to handle before we say that we are totally ready. First of all, in our observer, to prevent memory leaks, I will say observer.unobserve, so we are stopping the monitoring once an image is inside. I say image.target, which will basically mean we are getting the whole image out of the monitoring flow. This will prevent memory leaks. Okay, that's for one. But here in the for each, I'd also like to do something else. We don't want to receive anything unexpected when we are loading the image. So I set the source value to be nothing. And I store it first of all in the image.dataset.source. Instead of source, I could also say birthday or I don't know, any other. The dataset property serves as a store of value for the image, and I set it equal to the image.source. Now this image.source is actually going to be the image or the URL that should be displayed. And I set the image.source after I stored it to an empty string. Okay, but now the image will never load. So after we call the fade-in animation, after it all ends, I say image.source equal to the image.dataset.source. This will ensure that the image is loading nicely and there is no unexpected issues that you run into. Now we are done. If I start scrolling now, as 10% of the image is in the screen, it starts loading them in. If I check the network tab, even less images are downloaded than if we were to simply say lazy loading. And as I start scrolling down, more and more images are downloaded. So it's even more efficient than the one-line solution. This was it for our solution. If something's not understandable about the code, our HTML, CSS, or our JavaScript, please comment down below. We are more than happy to help. And I hope you found value in this video and enjoyed it. If you did, please consider giving us a like, maybe even subscribe. And other than that, I hope to see you in the next one. Happy coding and God bless.